Hi everyone, welcome to the video on additive and subtractive mixing as well as swapping to HSB color mode using p5.js. I'm trying to get everything into one video. There's a ton of stuff that has to do with color. There's definitely going to be things we miss. As a reminder, there are office hours, there are breakout sessions, and there's always the ICM Slack that you can drop into to ask instructors or your peers questions. Please make sure you're utilizing those resources. Also, as in any video, you may want to have open the P5 editor to just a blank page so that if we are trying things that you think look interesting to try as well, you can do that. Remember that you can pause this video at any time. You can also go back and rewatch. And again, if any of this video does not do it for you, please make sure that you reach out to someone. We are more than happy to help. So the very first thing we are going to do is just establish the difference between additive and subtractive color mixing. And this is something I recommend doing with students if you think they can handle it in a remote setting. During the school year, this is something I spend roughly a day doing in class because it is very different from other ways students have seen color and maybe even different than how you have seen color. So my launch to this, which you are going to see now, is this program that I made almost 3 years ago. You'll see as we scroll through it that I took away the background to make sure the colors show up and blend the way I want them to. I also have turned the stroke off on all of my shapes. This is a very personal preference. I think a single pixel stroke is very ugly. I prefer strokes to either be thicker or non-existent. I just want some kind of decision to be made about them. And to help us see, I've taken the stroke away. And then as we scroll down, you'll see that I have a fill of red. It is all in the R, there is no G, there is no B, and there's this 1 at the end. The last number at the end represents opacity and transparency. So if my number is 1, that means it's really opaque, it's really transparent. It's going to be see-through. If you don't put a fourth number here, which up until this point many of you may have not been putting a fourth number, it defaults to 255 when we're in this color mode. So if that looks new to you, that's fine. If you do want to experiment with making things that are see-through so that you can layer shapes in a really interesting way, please feel free to start adding transparency. I have a red transparent circle, I have a green transparent circle, and I have a blue transparent circle, and depending on how comfortable you are feeling with the P5 coordinate plane, it may be apparent to you that all of these are going to be overlapping. Because they're transparent and overlapping, you're going to be able to see through them, and you're going to be able to see the way the colors are mixing. So I would encourage you to just maybe pause the video and take a second to think about, what do you think happens when red and green mix? What about when green and blue mix, or when red and blue mix, or when all three of these colors mix? What kind of colors are you expecting to see on the screen? And once you've done that, and you have like a clear vision in your head of what you think is going to show up, you can go ahead and hit play, and you're going to see my circles get light and slowly darken as they mix together. So for most people, this is not what they expect when they think about color mixing. The red and the green mix to make yellow. The red and the blue mix to make magenta, which seems honestly pretty on point. And then the blue and the green mix to make cyan. But maybe what throws people the most is the center where they all mix is not like a muddy, gross color. It's pure white. And there's a reason for that. When we're mixing things on a screen, we're using light in a process called additive mixing. Your computer is literally learning how to turn light bulbs on and off to mix the colors you want, and the 3 light bulbs that it is triggering are always red, green, or blue. If you are of the age to remember like those old bubbly TVs that maybe you got way too close to and your parents freaked out about, those lights you saw were doing the additive mixing. Subtractive mixing is what most people are used to doing in art classes when you're mixing paints or markers or crayons or colored pencils. And the reason it's called subtractive mixing is those pigments are actually subtracting colors from the light spectrum so that you actually see the colors that are not there. It's a really cool, really trippy thing to talk about with students. It's like wild to them, all of these ways that the light spectrum interacts. But it is worth noting that when students think about what to add to their colors or how to change their colors, it is not going to be an intuitive process. Adding yellow and blue, for example, is not necessarily going to make green when we are dealing with an additive mixing process. All of our additive mixing colors in the normal color spectrum are 0 to 255. We are always mixing the red, then the green, then the blue, and that is the default for working in P5. Now, that is fine, and there are a lot of resources out there to help you do that. One that I strongly recommend is the Adobe Color Picker, which is this website here. We will make sure that this is in your resources in Google Classroom. I'm really zoomed in because I was showing this to students. Adobe Color Picker does two very useful things. One is that it helps you make color palettes, and if you have students who maybe do not have a very strong arts background, it might be hard for them to decide what looks nice together and still gets like good contrast for having, good design principles. So this can be really useful in organizing a palette. Up top you can change how that palette is organized. I always like complementary palettes myself. And then on the side you also see that you can switch color mode. The default is RGB, so if you take one of these colors like this blue that I'm currently selecting, these three numbers, 28, 44, and 163, those are the RGB values that you would plug into a fill or a stroke in P5 in order to generate that color. This is super useful to students. It will probably be super useful to you. I cannot recommend enough that if this interests you, you go ahead and use it. Some people, though, do not like this, I'm going to use a tool in order to get a code to plug into my program method, and they want something that's a little easier or just something that works a little bit differently. And that's why P5 has multiple color modes that we can access in order to get different results. So the second color mode that we can switch to is one called HSB as in boy, although you will sometimes see it as HSV as in value. And what that does is it still takes three numbers, but HSB will take in a hue. The hue refers to where in the rainbow are we? Are we a blue? Are we a green? Are we a red? It will take in an S for saturation. Saturation is how much of the color is present. A really saturated color would be like a highlighter where it's like so vividly yellow or so vividly pink. Something not very saturated, a good example I always point out to kids is if they have ever seen construction paper that has been up on a wall or a bulletin board all year, maybe with something covering it. When you take down the thing that's covering part of it, you will see a more saturated color than the thing that has been bleached by sun. The sun has taken away some of that pigment and lowered the saturation. It's kind of grayed it out. The value then is how much white or black is present in that color. So it's like how dark or light is this. That's different than saturation. Saturation is about vividness. Value is literally about the brightness, the amount of white or black in it. Again, this is like a big art concept, and if this is something that you feel is hard to grasp, you can always stick with RGB, or you can just play with the numbers until you get something you like. In addition to this diagram, which you will see on our GitHub website, I like this color wheel as a way to predict colors. We're going to come back to referencing this, but this is one of the reasons why a lot of students will prefer HSB, is because it's really easy to predict what type of color you're getting based on the hue you enter. So one of the other big differences between HSB and RGB color modes, in HSB everything is out of 255. Sorry, in RGB everything is out of 255. In HSB, hue is 0 to 360, it's going around a circle. Saturation and value are out of 100, and that fourth value for transparency opacity is out of 1. So it's 0 to 1, often decimal values between there. It is much easier to predict these colors, which is what we are going to look at right now. So if I go over to my canvas, if I put a fill in on this shape and I type a few random values like 128, 67, 100, and I hit play, before I hit play, I don't really have a good way of knowing what this color is going to look like unless I spend a lot of time thinking about my additive mixing and thinking about the amount of red, green, and blue I'm adding. Oh, it actually made a pretty nice purple. If I am in HSB color mode, which I can either declare in setup or I can declare above each function in draw, I would write color mode HSB. Now when I hit play, you're going to see I get a much different color because these numbers are being interpreted in much different ways. This 128 is deciding where on my color wheel am I. We can see that 128 would fall about here, which explains why in my program I'm getting this green. 67 refers to the saturation, how vivid this color is, and 100 refers to the brightness. So you can see this is like a very bright green. If I were to up this 67 to 100, you'll see that it's so bright that it's hard to tell. You'll see that it gets even brighter. If I were to drop it down to 20, you'll see that it becomes more pastel. It grays out a little bit. If I have it drop down to 20 and I also drop the brightness down to 50, you'll see that I start getting more of like a darker kind of foresty leaf colored green. So already these are easier numbers to play with and predict what's going to happen. If I didn't want it to be this green color, if maybe I wanted it to be more of a blue, I could work my way down the color wheel to something more blue, maybe 190, and see what happens when I plug that number in. So now I have more of like a gray slate blue. If I wanted it to be more vivid, I could bump up the saturation. So now we can see it getting brighter. I could bump the saturation up to 70. It's getting brighter, but it's still pretty dark. If I wanted it to be like a true light cyan, I might bump the brightness up, and we can see it starting to get brighter and brighter. And if I bumped it up to 100, we could imagine it would even be a little bit brighter than this. It is completely up to you and your students which you want to use. I have had students who love HSB. I have had students who love RGB. They are both really valid options. The last thing I just want to name is that there are other ways to input color in P5. There are a set of HTML color words that are recognized in JavaScript. They are strings, meaning they need to be put in quotes, but if I were to put in blue, it would fill my circle to blue. The problem with these color words is that they are limited. There's a good amount of HTML words, and if these are something you're interested in, that's a good Google search or a good thing to ask on Slack. We can help you find those. But like eventually you're going to run into a color that's not perfect that you want to change, and you're not able to do this in this method. You would need to use RGB or HSB. You can also use something called a hexadecimal code. Hexadecimal code is a way of representing the same RGB and HSB values using base 16 number systems. So ultimately it takes less data to encode that. This is something I don't often explain to students unless they have a very strong background in web design and web development, meaning that they are very familiar with using these numbers in an HTML setting. If you would like to address that with students, it's completely up to you. The last thing I want to call out is that this color picker also has options for HSB support. Here they do call it HSV as in value, but if you want to keep using this, you can swap it over and you'll see that it will give you the three numbers in HSV and HSB form. For students, a big conceptual misunderstanding is that HSB and RGB somehow give you different colors. That's impossible. They give you the same colors. Every color is available in every mode. This beautiful gold color is available in HSV and RGB. You just give the computer different inputs so that it knows to mix them differently. Again, please make sure that you are introducing this with students and with yourself in a way that makes sense, and you are utilizing the one that feels most comfortable. If you feel like you need a challenge, please feel free to experiment with which ones you are using. And again, if you have any questions, if you want to learn more about hex numbers, if you want to learn more about those HTML color names, just reach out. We are happy to find you the resources and help you out with whatever you need. Thanks!